is a world in conflict. But in this world of opposed force, there is order. Nature has its own balance. To each action, there is reaction. Out of violence, tranquility. But even in the peaceful scene, the conflict of energy and mass continues. This opposing force extends into the biological world, antagonisms in the animal kingdom. Though not as dramatic, conflict in the plant world goes on unrelentingly. Parasites. Fungi which feed upon the life of other plants. Of microorganisms in the soil. Though he did not know why, primitive man searched for certain molds to treat some of his ills. In his crude medical practices, he had begun to employ biologically antagonistic forces. He was using a phenomenon which even today is understood incompletely. From a beginning such as this comes the story of modern antibiotic therapy. Over the years, Tyndall, Pasteur, and later Fleming witnessed a new phenomenon. Some stray impurity found its way into Fleming's laboratory and onto nutrient medium. He observed the phenomenon of antibiosis, a biological antagonism, one microorganism inhibiting another. This antimicrobial action is a complex one, which even today is not fully understood. Slowly, the men of science began to study the phenomenon and the possibilities. Down through the history of man, infection, the growth of pathogens within the body, has taken its impressive toll. Within man, there was a counteractive force against disease, the thin line of body resistance which allowed man to survive in the world, surrounded by pathogens. Body resistance wasn't completely effective, however. Diseases welled up again and again against this protective barrier. A few anti-infective drugs were developed, antisera, vaccines, and heavy metal antiluetic drugs. Each helped to reinforce the protective barrier, but only against the one disease. Sulfonamides opened the era of comprehensive chemotherapy. For the first time, medicine had an agent which could act upon a group of organisms, though the spectrum was relatively narrow. But it was penicillin which revolutionized the therapy of diseases of infection. It was the first biological antagonist of disease, the first true antibiotic. Bacitracin, more recently developed, is effective within the penicillin range of activity. Streptomycin was the second true antibiotic to be developed. Its spectrum complements and somewhat overlaps that of penicillin. When used in combination, the two drugs serve as a relatively broad-spectrum antibiotic. Used alone, each is effective against its own group of diseases. Polymyxin, another of the antibiotics developed earlier, is available for systemic use. Its spectrum is somewhat similar to streptomycin, although it is not effective against the tubercle bacillus. And then from the molds came antibiotics of even broader usefulness. Chloramphenicol, aureomycin, terramycin. These broad-spectrum antibiotics are revolutionary. But although they have similar spectra, there are significant differences among them. While each of these antibiotics has its value, it is only fair to point out the limitations which distort the otherwise perfect therapeutic picture. Every drug has toxicity. and side reactions such as occasional nausea or diarrhea, and infrequently yeast overgrowth occurs. The practitioner recognizes them and learns to exercise judgment in each case. Another limitation is the development of resistant strains of bacteria. The pattern varies with each drug. For example, strain resistance to streptomycin develops rapidly. The broad-spectrum antibiotics, on the other hand, follow the penicillin pattern of slow resistance development. In any case, the benefits far outweigh these disadvantages. The earlier drugs continue to be useful, just as today's drugs will be useful when even newer ones are developed. Despite their value, it must be kept in mind that the antibiotics are only a supplement to body resistance. This symbolic line of resistance consists of a complex of elements: antitoxins, lysins, agglutinins, phagocytes, endocrine responses, and other undetermined factors. For a moment, we'll take a portion of this line to symbolize arbitrarily all of body resistance. When the body defense mechanisms are strong and efficient, antibiotics, of course, are not necessary. In general, they are indicated in 4 situations where resistance cannot handle the infection. If an infection is caused by exceptionally virulent organisms, resistance is overwhelmed. Antibiotic administration enables resistance to resume its effectiveness. When there are too many bacteria, body resistance is unable to cope with the number. Again, the antibiotic may enable resistance to resume its effectiveness. When resistance is low, the clinician must rely primarily on the antibiotic to handle the infection. And, used prophylactically, the drug suppresses the growth of bacteria. To be acceptable as a therapeutic agent, an antibiotic should possess certain desirable characteristics. It should be easy to administer. It should have a wide margin of safety between the therapeutic dose and the toxic dose. It should be readily absorbed into the body. Its antimicrobial action should not be inhibited by the body fluids, allowing the drug to act in any location. It must be effective against invading organisms in vivo and throughout the range of the body temperatures. It should not interfere with phagocytic activity. It should not antagonize the effects of other agents. And finally, microbial mutation causing bacterial resistance should not develop readily. Terramycin, the newest of the 3 broad-spectrum antibiotics, was discovered in the soil. It was developed from an actinomycete, Streptomyces rimosus. It was originally extracted and concentrated as the crystalline form and has always been available in this pure form. As a result, toxicity and side reactions have been minimal. Terramycin is amphoteric. It forms alkaline and acid salts. Both terramycin and its salts are therapeutically active. The structure of terramycin is unique in nature. The molecule contains no chemical groups known to be harmful. The carboxamide group is similar to those which link amino acids in proteins. The dimethylamine group explains the solubility of terramycin in acid, while the oxygen in these systems accounts for its solubility in alkaline solution. Terramycin maintains its potency for years at room temperatures. Among the physical properties, the solubility should be mentioned. The salts are soluble in acid, in alkaline water, and in the common organic solvents, forming relatively stable solutions. These useful properties complement the high antimicrobial potency of terramycin, which can be observed readily in nutrient media. In vitro studies foreshadow the therapeutic applications and the clinical effectiveness of the drug. Any broad-spectrum antibiotic is effective against an impressive list of microorganisms. However, as strains develop which are not affected by the antibiotic, such a list is only a guide to therapy. In general, the gram-positive bacteria which are sensitive to terramycin are these. The sensitive gram-negative bacteria are these. Also sensitive are spirochetes, rickettsia, protozoa, and even some of the larger viruses. These are the terramycin-sensitive microorganisms. For the various types of infections which occur in the body, there are several dosage forms of the drug. The intravenous preparation may be used in those severe cases where high and immediate concentrations are desirable. Oral suspension may be employed. Concentrated drops may be used orally in infants, instilled beyond the region of the taste buds. Or dosage may be in the form of capsules or tablets. The orally effective antibiotic must not lose potency in the acid gastric juice or in the alkaline fluids of the alimentary tract. It must be absorbed into the bloodstream to give rapid therapeutic concentrations which last for several hours. Periodic administration of terramycin, approximately every 6 hours, maintains these concentrations. However, the concentrations are assured only if nothing interferes with the absorption. Coincidentally administered alumina gels physically adsorb the drug, which decreases absorption. On the other hand, milk, which helps to eliminate gastric distress, does not interfere with absorption. This broad-spectrum antibiotic alters the flora of the bowel, which incidentally is a valuable adjunct for intestinal surgery. There are numerous clinical conditions in which an antibiotic is indicated. Because it is carried in the blood to all parts of the body, it is effective both in the body tissues and in the bloodstream. Bacteremia is a serious complication even in this day of antibiotics. Terramycin's effect in this disease is positive and rapid, as it comes in direct contact with the bacteria in the bloodstream. High blood levels give high tissue and body fluid levels, which lead to high tissue concentrations of antibiotic. Infections in tissues, therefore, also respond. Where the blood supply is poor, however, infection cannot be handled readily. As an example, abscesses are diminished only by natural healing, which may be assisted by the antibiotic effect. In all such cases, proper surgical management should be exercised. Urine is another body fluid in which terramycin is effective. Since the drug is concentrated and stable in urine, it is useful in non-obstructive infections of the tract and associated structures. Here, the infection is controlled both through the urine and through the blood. Nonspecific as well as venereal infections normally respond. And when the causative organism is sensitive, diseases of the genital tract may be treated successfully. These infections are vaginitis, cervicitis, endometritis, and salpingo-oophoritis. Infections occurring during pregnancy, such as pyelitis, can be controlled with proper handling. At the same time, the antibiotic traverses the placental barrier into the fetal circulation. However, there are no adverse effects. Postpartum infections are also successfully controlled by the drug. As antibiotics are carried in the bloodstream, they are effective not only in these deep infections, but in superficial disorders as well. In addition, infections of the skin and of the eye may be treated by topical therapy. Severe infections, such as meningitis, may require very intensive antibiotic therapy even when the organism is sensitive. Terramycin is absorbed by brain tissue, penetrating the blood-brain barrier quite well during infection. Although ineffective against the common cold, antibiotics are useful in prevention and treatment of its complications: sinusitis, otitis, tonsillitis, and descending infections, laryngitis, tracheitis, bronchitis, bronchopneumonia, and the other pneumonias. Mixed bacterial and pneumococcal pneumonias of the classical type can be treated effectively during all stages. Morbidity and mortality have been significantly decreased. In addition, terramycin is employed in viral and rickettsial types of atypical pneumonia. These diseases are reported to respond only to the broad-spectrum antibiotics. While X-ray findings may take time to regress, symptomatic improvement occurs soon after administration. Here, too, morbidity has been greatly reduced. The list of diseases affected by terramycin is long, but necessarily broad-spectrum activity will not cure all infections. As a guide to therapy, it is good clinical practice to isolate the organism, identify it, and test it for sensitivity by exposing it to graduated dilutions of the antibiotic. This is advisable as it may be a naturally resistant organism such as Proteus, or the frequently resistant Pseudomonas aeruginosa. Even some of the more common bacteria, such as Staphylococci, possess resistant strains. Antibiotic therapy can be started immediately after the culture is taken and sent to the laboratory. In this way, immediate broad-spectrum activity is assured. In most cases, it can be continued until the infection is controlled. No drug is perfect, but here at the bedside, perfection can be approached therapeutically. Ultimately, then, the responsibility comes back to the physician, the man who applies the skills and drugs of modern medicine. The tools of our culture are as effective as the men who wield them.